Hello geometry team and welcome to Unit 10. And for Unit 10 today we're going to be talking about surface area and volume and for three-dimensional shapes. So let's look at some three-dimensional shapes here. So we have a couple of different kinds of shapes that we're going to be focusing on in this unit. The first ones that we're going to talk about are going to be prisms. And a prism is a solid with two bases that are congruent and parallel. And so here I happen to have two congruent triangles that are the same size and shape, so all their side lengths are the same. We learned that back in triangles. Corresponding parts of congruent triangles are congruent. And then they're parallel, which means that all of these side lengths connecting those bases are also the same length. So whatever your height is here is the same as your height here. Okay? This shape on the bottom base can be any shape. So this is a triangular prism, but if you happen to have a pentagon on the bottom, you would have a pentagonal prism. And if you had trapezoids that were congruent and parallel, it would be trapezoidal prism. And in this case, they turned the bases on their sides, and that's fine as well. And so an example, here I have a triangular prism. I have a triangle on top, a triangle on bottom. Here I have a hexagonal prism. So I have a hexagon on top and a hexagon on bottom, but they're all parallel, so it makes a bunch of rectangles around the side. To make it a little more clear, I can put some color inside it, see if that helps. So now you see the hexagon on top, the hexagon on bottom, but even if I lay it on its side, this is still a base, and this is still a base. So the two congruent faces are your bases in a prism. Okay? Knowing that now, we're going to focus today on surface area. So surface area of any 3D shape is the area of all the faces, including those bases that are congruent. Okay, and so the surface area for a rectangular prism is going to be this area of all 6 rectangles you can find. And in a rectangular prism, you're going to end up having 3 pairs of congruent sides. So your bases, by definition, are congruent. And so you would have your top and your bottom would be your bases, and they are congruent. In this particular picture, they have a length and a width to find their area, and there would be 2 of them, so we'd have 2 length times width. But we also have the faces that go around it. So there will be 2 that are front and back that are also going to be congruent, and their area is found by doing this width times this height. And there will be 2 of those, so I'll have 2 width and 2 height. Then I'm going to have a left side and a right side, and that's really hard to show on 3D here, but you still are going to have a left and a right, and they're going to have the area found using the length times this height here. Remember, all the heights will be the same. So length times height will give me this area, and then there's 2 of those faces. So I end up adding 6 faces to get the surface area of my rectangular prism. Now notice it also says cubes here. A cube is a rectangular prism. It just happens to have all squares on all sides that are all the same. So for a cube, you could just do the surface area equals 6 and then your side squared, because the side squared will give you the area of this face, and then in a cube there will be 6 of them. They will all be the same. So to find the surface area of this rectangular prism, I'm going to focus, I think I'll start on the bottom first. So this one has 7 times 13 to give me the area of this bottom rectangle. But I know there will be 2 of them because that's a base. There will be a top and a bottom. So I know there's 2 of those. Then I'm going to find the area of this left face. It is 7 along the bottom. Ooh, how tall is it? Well, remember, all these heights are the same. So it's got a 9. So I'm going to have 7 times the 9. But I know that there will be another matching face over here, so there will be 2 of these. And I've already done bottom and top, left and right, so now I need to do the front and the back. So here's the back side. And its top and its base, or this length right here, is this 13. And then to do its height is going to be the 9, because that height is the same all the way around. And again, I know there are 2 of those. So I've used my length, I've used my width, I've used my height, and they've all been included. So this will give me my full surface area. So my full surface area is going to be, this part will become 182. These 2 green faces together will come out to be 126. And the 2 orange ones together will come out to be 234. So my total surface area is going to be 542 square feet, because remember, we are just finding the area of all these shapes. And so you're really taking all of those faces out and just finding the area of all 6 of these rectangles as if they were laid out flat. You're finding an area. Area is always in square units. Alrighty. All other prisms, you have to work a slightly different way because they don't necessarily have any matching sides. Their bases are always going to be congruent because that's your definition of a prism. We said that a prism has 2 bases that are congruent. In this case, I have triangular bases being congruent. So I know that I will have 2 triangular bases. Okay, so here I have a triangle base and a triangle base. But to go around the sides, those rectangles around the sides might be all different sizes. So you're going to have to add all the other faces in, and that will give you your total surface area. You can do that individually if you choose. You could do the area of this rectangle, add on the area of this rectangle, and then find the area of the front one here and add those all separately. A shortcut to that is to find the lateral area of all of these sides in one big piece. All of the faces of my triangular prism make one big rectangle, and it has a height. That's the height of my prism. The length around this giant rectangular face is the distance around my triangle on top. And so that's actually the perimeter of the base. And so one way to find this lateral or side surface area is to do the height times the perimeter of the bases. And so that gives you your lateral area. So you could do that, height times perimeter, instead of finding the area of all the faces individually. Then to find that gives you your lateral area. Okay? Then your base area is still just going to be the area of the base times the number of my bases. So my total surface area becomes the 2 bases added together plus the height times my perimeter, or plus all your faces added together, will give you your total surface area. So you've got 2 possible ways to find your surface area. You can either add up literally each separate face that you find separately plus your 2 bases, or you can find the area of your 2 bases and do the height times the perimeter of your base and add all that to get your surface area. I'm going to use this second one right here because I'm a mathematician. Mathematicians want to take shortcuts. We want to do stuff that's shorter. So first, to find the area of these bases, I'm going to notice that, oh look, they are right triangles. I have a right angle here. So this is going to be the base, and this is going to be the height of that triangle. So I know this base is 9 and this height is 12. So the area of this base is going to be 1/2 base times height, which is 1/2 of 9 times 12. And notice for b, this is a little b because it's just a linear base. When I use a capital B, I'm talking about the area of a base. So my little triangle is going to be 1/2 of 9 times 12, which is going to be 54. So I know that the area of this base is 54. So I'm going to use that as my base here. So I'm going to have 2 times that 54. And then I'm going to add in the height is 16 times, and now I need to find the perimeter. I need to find this length around my triangle to get this lateral area. And so I know for my triangle it's 9 plus 12 plus this is 15. So I'll do 9 plus 12 plus 15 for that perimeter. And altogether that should give me my surface area. So the 2 times 54 comes out to be 108. And then when I add the 9 plus 12, that's going to be 21 plus 15 is 36 times the 16. When I do this 36 times the 16, I end up getting 576. And so together, my total surface area is going to be 684 meters squared. So this is my total surface area for this triangular prism. Skipping down here now to my other prism, this one you have to look and see, where do I have congruent faces? I have a trapezoid here and a trapezoid back here that are congruent. So this is a trapezoidal prism. So I'm going to have 2 bases that are trapezoids, and then I'm going to have 1, 2, 3, 4 faces to add up. And I can either add up all of those 4 faces separately, or I can do the height of my prism times the perimeter of the trapezoid. Now be careful when the when the prism is laying on its side. If your base is hanging out in front here, the height of your prism is actually going to be laying down, because you had something that was standing up and this was the height. But if you lay it down, the height is now going along here. And that's what's happened in this one. Instead of the trapezoid being on the bottom, these trapezoids are in front and back. So the height of your trapezoid is now running along this way. So that's your 15. That's your height of your prism. So we're going to just keep that in mind when we're doing this. Now, to find the area of my trapezoid base now, I'm going to have to come over here and focus just on this trapezoidal base. So I'm going to focus on it now and ignore all this other stuff for now. To do just the trapezoid, I need to find the area of a trapezoid. And to do the area of the trapezoid, I have to average my bases, so 18 and 23, and divide it by 2, and then multiply that times this height of the trapezoid, which is 12. Okay. That's going to come out to be, let's see, 246, I believe. So that's the area of this front trapezoid. So I'm going to take that now and put that into my formula for the surface area. So that base of my trapezoid was 246, and I know that there are 2 of those bases. There's this front base, and there's this back one. Now I need to find the area of all these sides, my lateral area here in green. To do that, I'm going to take the height of my prism, which is 15, and I'm going to multiply it times the perimeter of my base. And so let's go around my base. I have this number is 12. This one is 18. This one is 20. And then along the bottom of my trapezoid is 23. And so that's going to give me this distance around in my trapezoid. And then times the height will give me this whole lateral surface area connecting those two trapezoids. So my surface area is going to be, let's see, 492. And then this was supposed to say plus right here. Mrs. Stern, get a grip. And now I'm going to add in this lateral surface area that I got from doing all these side faces. That's going to come out to be 1,095. And so together, my total surface area is going to be 1,587 feet squared. Okay. Coming over here, again, I have a trapezoid in front that I would find the area of, and then my 4 rectangles around the side. For this one, I have a triangular prism, so I would find the area of these 2 triangles, so 2 times those triangles, plus these 3 faces that connect them. And so again, that would be your height times your perimeter to get that total surface area. Let's do one more of these before we go on to our last shape. So again, to do the area of this base, I'm focusing just on this triangle. And so the area of my triangle is going to be 1/2 of my base, which is 8, times my height, which is 15. And that's going to end up giving me, see, 8 times 15 times 1/2, that gives me 60 for the area of this triangular base. Well, that is the base of my whole prism. So I will have 2 of those 60s. Then the perimeter of this whole thing, oh dear, I have the height is 15 and the 8 is this, but I don't have the 3rd side of my base. I'm going to have to calculate it. Welcome to math. Well, I know this is a right triangle, so I know that I can do, let me get another colored pen so I can stick with this. So to find this guy, I'm doing a Pythagorean Theorem. I have 8 and 15. I need my hypotenuse of this triangle. So I can do 15 squared plus 8 squared equals c squared. And so this is going to give me 289 total is c squared. And then when I square root both sides, the square root of 289 is going to be 17 equals my c. So I know that this slant here is 17. So now I can find the perimeter of this base by doing 15 plus 8 plus 17. And that's going to total, let's see, 25, 35, 40. Yes, 40 is my perimeter. And then this height, remember, is the height of your prism. So we did a height of a triangle. Now we're going to do the height of the prism. The height of my whole prism is the height connecting my 2 bases. So this is the height of that whole thing, and oh good, they gave that to me. That's 21. So I'm going to come in here and put that 21. And I know that my 2 bases plus this lateral area of all the sides will give me my total surface area. So that's going to end up giving me 60 times 2, which is 120, plus 21 times 40, wow, that's 840. And so your total surface area is going to end up being 960 square inches. So this is going to involve you being very organized in keeping track of what things are which. We talk about area of bases, we talk about bases of a little triangle, we talk about the height of the triangle, we talk about the height of the prism, and you have to keep straight which one is which. So be careful with all that. Lastly, we're going to have cylinders. Now, cylinders are a lot like a prism because cylinders have two congruent bases that are connected by a rectangle. But in this case, the bases are circles. So it doesn't get to be called a prism because the bases are not polygons. Instead, it's called a cylinder, but it still works the same way. My surface area is going to be two bases plus whatever that lateral surface area is, whatever the area of this is wrapped around the side. And so you have your cylinder with a circular base and its lateral side here. So to find its total surface area, I'm going to have the two circles on top and bottom, and then I'm going to have this lateral area. And if I open that out and lay it out flat, you'll notice that this lateral area is really a rectangle. And its height is the height of your cylinder. Here's the height of my cylinder. It's the height of this rectangular lateral area. This distance around to make the length of my rectangle is just the distance around my circle. And so this is going to be this perimeter that I would have used up in my prisms is now going to be the circumference of the circle. So my lateral surface area here, the area of this all wrapped around the side, is going to be the perimeter of my circle times the height. Well, to get the perimeter of a circle, that's your circumference of your circle. And so I'm going to do, to find my lateral area, it's going to be my circumference times my height. Well, guess what, folks? You have a formula for circumference. It's 2 pi r. So our final formula for this green lateral area, for this area wrapped around my cylinder, is going to be 2 pi r for your circumference times your height. We're going to take that lateral area and add it to the two bases. Well, my two bases are both circles, so their area is going to be pi r squared. So I have two of my pi r squares to give me two bases, and then I have the circumference times my height to give me my lateral area. My total surface area adds all that together. So coming over here to this example, to get my total surface area, I'm first going to need to find the area of both of these bases. So I'm going to have two of those bases. Those bases are circles, and so they're each going to be pi r squared. So I'm going to put pi and r and squared in here. Well, how big is my radius? They gave it to me. It's 11 yards, so I'm going to put that in here. That gives me the area of these bases. But now I need to add in my lateral surface area, the area all wrapped around the outside here. For that, it's a giant rectangle, and its area is the circumference times the height. The height is 26. That one was pretty straightforward. To find this distance around, I'm going to have to do 2 times pi times my radius. But once again, my radius is the same. It's just that 11. So I can put it in here. And now I'm ready to find my total surface area. So my total surface area, I'm going to start with the two bases. The area of these two bases is going to come out to be 242 pi's, and I'll figure out what that is in the end. And then over here, I'll do 26 times 2, and that's going to be 52, times 11 comes out to be 572 pi's. Then I can get my calculator out and plug all this in, and my surface area comes out to be, let's see, 4, 7 and 4 is 11, 6 and 2, 814 pi's. This is what you would put for an exact answer, but we can go ahead and figure out what pi is and round it. And when you put that in, you end up getting 2557.26-ish. Remember, we had to round this, so your rounding may vary depending on if you use the pi button or 3.14. And either way, we can't leave our numbers naked. And so we come over here and go, okay, it was in yards, but since I'm finding an area, it will be yards squared. The same thing is going to apply even if your cylinder is laying on its side. So my bases are over here, and then the height of my cylinder is actually running this direction because I have taken my cylinder from standing up and laid it on its side. So its height is running horizontally here, and that's okay. So for this guy, again, to find my total surface area, I need 2 of the bases, and then I need to add my lateral surface area. For my bases, I have circles, so it's going to be pi r squared. But oh dear, I don't have my radius here. I'm going to have to figure it out. So if this I'm given is my diameter. So if I cut that in half, my radius comes out to just be 7.5. So I put the 7.5 in there. Now to do the lateral surface area, so the area around this whole side is going to be the perimeter times the height. My height is this 9. The perimeter will be the circumference of this circle, which is 2 pi r. And we discovered that the radius was 7.5. Now it's just a bunch of calculations. So let's plug them in. Let's see, 7.5 squared times 2, that's going to be 112.5 pi's. And then I'm going to add in, let's see, 7.5 times 2 is 15, times 9 comes out to be 135 pi's. And so my total surface area, you can plug that in, put it in with pi, and you end up getting 777.54. And then you don't want to leave your area naked, so you say, okay, my lengths were in meters, and so my area will be in meters squared. Okay? One final example now. What if I give you this shape and say to find its surface area? Well, this is a hexagonal prism. And so for this hexagonal prism, I'm going to tell you that its area of its whole base, what if I just tell you the area is, oh, I don't know, 75. Let's go ahead, and the height, let's say that it's 20. Then let's go ahead and calculate now the total surface area of this. Well, to find surface area, remember I'm going to do 2 bases, and then I'm going to add on that lateral area, which is my perimeter times my height. Okay, and so I would need to know my perimeter, my area of the base, and my height. Okay, so let's go in and go, okay, my surface area would be 2 times this 75 plus my height here is 20. And then I would have to calculate that perimeter, and either I would give it to you or you would calculate it based on what I gave you here. Let's go ahead and say that this area, I'm going to make something up. This is not actual. I'm making this all up as I go. Let's say that this length here is going to be, oh, I don't know, make it up, 6. So if I had a 6 here and 6 sides, that would give me a perimeter of 36. And then I could go from here to find my total surface area. Please don't go and calculate if I made up that number right or not. This was all made up on the fly. So we're just practicing using the formula. Don't at me. So this will be 150 here. And then my lateral area will be 720. And so my total surface area is going to come out to be 870, and whatever my units were squared. So typically for these more complicated bases, I'm either going to give you that area of that base, or I'm going to make it pretty straightforward to find it. Anyway, geometry team, thank you for starting Unit 10 with me, and we will see you next time.